Welcome back to our lecture series on automated machine learning. Now we're talking about a more global view on all these kind of components AutoML is using, so more as a broader overview on interfaces of automated machine learning. So we had before interfaces from the perspective of input-outputs. Now we're talking about what are tasks being addressed by AutoML, what kind of approaches are there, and what can even be done in post-processing. But let's start with the overall workflow more. So how normally we're doing machine learning, right? We're starting with data, we pre-processing it somehow, trying to increase quality of our data. We then having an AI model, which should give us then some kind of predictions, insights, maybe even decisions and whatnot. You can even then going and making a loop out of that. And then often we call about meta learning, because meta learning is the process of learning how to learn. So we're saying we have seen, for example, similar data sets in the past. We have already figured out how to learn on that, what kind of preprocessing model and so on we needed, or what kind of updates we needed on weights of a deep neural network. All of that is meta learning. So we learn from previous more experience on how to learn, now how to learn on a new data set. But let's look into what AutoML actually can do for these kind of pipelines. So of course, it can deal with the data preprocessing, try to figure out what is a good data preprocessing. What kind of model do you actually need? For example, do you need XGBoost or do you need a deep neural network? If yes, what kind of deep neural network? Is it a ResNet? Is it a CNN? Is it a transformer? And so on. It can help you with the hyperparameters actually. So for example, deciding the learning rate of a deep neural network that we're learning quickly and efficiently with that. It can also help you finding the optimal architectures. So it can do neural architecture search for you and even defining your entire pipelines and say, okay, what is actually starting pre-processing? What is the model? What are the hyperparameters and all of that? Then what kind of approaches are typically used with automated machine learning? So a lot of things we will also see in the lecture series is on black box optimization. One of the things is Bayesian optimization. The other things are evolutionary algorithms one can use here. We tried out over the decades, or the community tried out over the decades, several of these approaches. Then we have to talk about efficiency, how we can leverage more insights and how machine learning models are trained to make automated machine learning more efficient. And one of the approaches we will see is multivariate optimization, but also others. We can, of course, talk about LLM-assisted optimization. So Gen AI can help us actually to find better things. For example, if we would like to generate code, we have to think about multi-objective optimization. If we have more than one objective, actually, what that actually means. So if we would like to trade off, for example, inference time and accuracy. And foundation models are also very important. As I discussed before with you already, foundation models that you don't need to do training anymore, but directly in context can learn how to get good predictions for a new dataset. Then for postdoc, different kind of techniques exist there. So very classical one is model ensembling and related to that also stacking. And interpretability of AutoML is also more often done post-hoc, and for example, deciding what are important hyperparameters, what are important design decisions, how stuff interact with each other. And a bit outside, but very related actually to automated machine learning, we will see that also a bit in the future videos, is benchmarking. So how can we compare different kind of models? How can we compare different kind of AutoML approaches and all of that? And of course, we also have to think about, always from the perspective, who's actually using these kind of systems? So who is the user group of AutoML? Is more the domain expert? Is this more the machine learning expert? Is something in between? So it really depends, but we need to consider always who are we aiming for, or for whom we are building our tools. Therefore, thinking about user groups in that global picture are quite important. Putting all of that together in one image gives me that kind of graphic, which is of course not covering everything which is there in automated machine learning, but I think very important trends and very important things you will also see in that lecture series. So to sum up that, AutoML can be applied to the full pipeline design or individual tasks of the pipeline. So you can maybe only use neural architecture search or only use HBO, or you can try to use it for the entire pipeline, right? Depends on you on what you would like to achieve. AutoML encompasses many different approaches for addressing the underlying problem. And there's unfortunately no one-size-fits-all method. That's a bit an unfortunate thing from saying we would like to have a system that we can press a buttons doing things. But in that kind of mindset that different stakeholders, different users need different things, different kind of interfaces, there is unfortunately no size-fits-all method, but I think there are very strong AutoML methods out there by now, which you can, for different kind of use cases, you can use very well. Nevertheless, since we are on a meta design level, there are diminishing returns in not choosing the best AutoML approach. So if you have something already very well performing, something reasonable as an AutoML approach, use it. Simply use it. Of course, there might be a slightly better approach, but that most of the time means you might invest a little bit less compute time in finding the best model. Doesn't need to be that the model is actually better or worse. So we are always on that kind of meta level on top of machine learning, is saying, okay, care about efficiency of AutoML, which can sometimes be drastic improvements and sometimes also minor. So overall, my recommendation is simply go with an AutoML tool, whatever fits you best. AutoML leverages different techniques, for example, post-processing, ensembling, stacking, and so on, to build even more powerful systems. Of course, you should consider, for example, can you afford it? Do we have the compute power for it, more memory consumption, more inference time, maybe less interpretable? So it's always up and down sides with all of these things. And then think about the user of AutoML and how to do proper evaluations. These are things often a bit underestimated, but I think they are super crucial if you'd like to build a very good AutoML tool, or whether you would like to decide what is your best AutoML tool for your application at hand. With that, I hope you get new perspectives on AutoML, and what it can do and what you can choose from, and all the little details you will learn in the upcoming videos. Hope to see you there.